All right. Again, this is Mohammad Malkawi, and uh, this is my second video for this course. Today, I will be talking about the design and analysis of algorithm. Let's start. I did talk about the syllabus in the previous video, so let's do the following. Trying to minimize this stuff so we can see more. And okay, oops. So the theoretical study of design and analysis of computer algorithms. Uh, when we talk about an algorithm, we have to always make sure that we have two major criteria. Number one, the algorithm is always correct. Pay attention to this word, always. Pay attention. Always means if you run the algorithm, try it for any type of input, it will always be correct. For example, if you and also it will always terminate. Let me do both. Always terminate, which means there is a time where you get your final result. Let's say if you are trying to find what is let me put it in writing here somewhere so you could see what I'm talking about. Let's say I want to say find all prime numbers. You know what a prime number is? A prime number is a number that divides by one or by itself only. For example, 3 is a prime number, 5 is a prime number, 7 is a prime number, 8 is not a prime number because you can divide it by 2 or by 4. So if you want to find all prime numbers and you need an algorithm, number one, I will tell you that this algorithm will not terminate in polynomial time. And here I'm using a new term which I will be talking about a lot. Will not be, let's say, if you want to find the prime number after trillion trials, let's say you have a trillion prime numbers. This is almost non-polynomial, which means you will not be able to find that in a reasonable amount of time, which you can easily compute. So this is not an algorithm. You cannot find an algorithm that finds all the prime numbers. You can find an algorithm that finds a specific prime number, but not all prime numbers that exist in the world. And the correctness, maybe the way you will find it, you say pick a number and try to divide it by 2, by 4, by 8, all the way by n, by the number divided by 2. If it doesn't divide, then it's a prime number. So the algorithm can be correct, but it may not terminate, or it can terminate but not correct. So we'll be talking about algorithms from this perspective. And that's what I meant by performance here. Now, there are two aspects of algorithm. One is the analysis and the other is design. So actually, let me just reverse these two, put design here. And the reason I put this, and I will switch them back again. Design algorithm which minimize the cost. I want to make a design, let's say, and I will say in a second what do I mean by an algorithm. I still have not said what an algorithm is, but let's say I want to design something, a means and a method, again, to compute or to find the prime numbers. That's a design. Analysis, I want to predict the cost of this algorithm. How long does it take to run in terms of time? Now, of course, when I say cost, it's really the time is cost. How much time do I need on my computer or a supercomputer or my laptop or my cell phone to compute and find to run the algorithm to the end. When I say to the end, which means until it terminates. Now, if it does not terminate, it's not an algorithm. I already have said that. So this is what we mean by the design and analysis. Design finding steps. Actually, before that, when I say the algorithm, okay. So what is an algorithm? All right, what is an algorithm? That's what, when I say there is a design, there is analysis of an algorithm. What is an algorithm? Let's be very accurate, and in fact, I have already posted an assignment to the group, or I have made an assignment, and uh, I will put it on Canvas. This is my definition, or the definition I have adopted from the algorithms book on the University of Illinois Urbana-Champaign, where it says an algorithm is what? It's an explicit, note, it's explicit, it cannot be implicit, very precise. So it is explicit, it is precise, so it's not uh, multiple type of words, it's unambiguous. You cannot have two different interpretation of the same, so it is unambiguous. It's mechanically executable. Mechanically here, when I say mechanically, I can also refer to computerized or programming wise. I can write a program that can implement it. So it is executable sequence of elementary instructions. So it's a sequence of instructions. Actually, those who have taken computer architecture and they have taken, or maybe computer organization and assembly, where each code which we write, eventually it has to translate into a very well-defined sequence of instructions. It cannot be ambiguous. An instruction say, go to memory, fetch, find the address, locate the word, fetch that into register. Once you have it in the register, go and fetch the second operand or second number. Let's say if I want to do an add, then use an add signal from the hardware to add these two numbers, put them in a register back, store them back to the memory, and end. So this is an algorithm. And there is another example here, which we put. Here is an algorithm for singing the annoying song which says 99 bottles of beer on the wall for birthday values of 99, for arbitrary values of 99. For example, here I have 99 bottles, keep singing until all bottles are gone. This is probably someone who wants to drink 99 bottles of beer. God knows what will happen to this person or to the ones who sing this. This is an interesting problem. Let's see the algorithm, how it goes. We'll start my algorithm. Although this looks like a programming language, it's not really. It's called a pseudo language. Let's say for I equal n down to 1, starting from, let's say, let me use change the color so I know I'm writing this now. So we'll say start from 99 until 1. So which means when you finish all the buttons. Now why didn't this go into red? Okay. And actually I will use the notation like this because this means this is like a comment. Okay, so start from 99 until 1, and then I start singing. First I will sing I bottles of beer on the wall, I bottles of beer. In reality, this, when I say I, it's 99 bottles. I will change that to Coke because I don't like beer, I don't drink it. 99 bottles of Coke on the wall, and then say the word 99 bottles of Coke. Actually, okay, so this is then the thing. Take one down, pass it around. I minus 1 bottles of beer on the wall. Actually, what this means here, it says take one. All right, let me continue. I'm sorry about the pause here, but going back to our algorithm just to finish it up. So this algorithm says start from number 99, you go until 1, take the first number from 99, first bottle, if you will, bottle of Coke, pass it around, take one down, pass it around, and then say I minus 1, which means 98 bottles of Coke are still on the wall. And we repeat this. When we say repeat until I equals 0, then once you are done with this, you go back here, go I bottles of beer, I bottles of Coke, 98 now. Now this point will say I bottles, it will be 98 for this round. Bottles of Coke on the wall, 98 bottles of Coke. Sing, take one down, pass it, take one, which means take the one which is number 98, pass it until then you go back and you start saying 97, 97, and you go all the way until you say 1 and then 1. So you took the last bottle and you say I minus 1 left, I minus 1 will be here, will be 0, 0 bottles left. Okay, until I equals 0. Now I equals 0, at this point no bottles of, sorry for keep changing that, no bottles of Coke left on the wall, no bottles of Coke, finished. And then we say go to the store, buy some more, and then start the song all over again. Note about the correctness here of the algorithm. I mentioned there is correctness and there is the termination. Does it terminate? Of course it will terminate, because if you start taking from 99 all the way to 1, eventually you will end up with a 0 bottle, so it will terminate. The correctness, is it correct? Yes, of course it's correct, because every time you take the numbers are reducible. So the starting from 99, you can subtract from 99, and you can keep subtracting until you reach 0. Now, if you had, for example, like some of the mathematical abstracts, if you start from n down to minus infinity, okay, or n down to minus 1. Now, when you have 0, you cannot subtract from 0 until you get minus 1 bottle. There is nothing called minus 1 bottle. There is minus 1. It's an abstract. So if you have the algorithm you want to sing until you have minus 1, instead, for example, if you do it like this will be a definitely incorrect algorithm. It does terminate. It terminates at 0, but it's incorrect algorithm. So this is the my first video. I'll stop right here because I don't want to make the video longer than 15 minutes. So I'll stop right here and start another video, and we can talk about that more. Thank you very much.